North Dakota's roads have always been resilient, convenient, and well managed, but now they're about to get smart. As part of the Smart I-29 and Transportation Management Center, or TMC project, led by the North Dakota Department of Transportation. This initial planning effort will determine the feasibility and funding viability of the following vision. The purpose of this project is to provide a roadmap to build an innovative statewide transportation management center in North Dakota that incorporates a smart corridor along I-29 to better manage the state's networks of devices and sensors, expand roadway monitoring and condition reporting to an around-the-clock year-long schedule, and streamline the deployment of advanced technologies. I-29 is a critical corridor for North Dakota in many ways. It provides connectivity nationally and internationally. The Pembina-Emerson point of entry is the fifth busiest land-based crossing on the U.S.-Canada border and has direct access to several significant freight distribution centers. Unfortunately, 5 of the 10 most significant freight bottlenecks on I-29 nationwide occur in the Fargo area. Growth is expected to continue, with up to half of future development in Fargo and Grand Forks expected within 1 mile of I-29. The I-29 corridor experiences crash rates 30% higher than statewide averages. Nearly 85% of crashes on I-29 occur when traffic conditions are unreliable, caused by inclement weather, an earlier crash, work zones, special events, or reoccurring traffic congestion. Nearly 2/3 of delays along the state's interstate system are caused by non-recurring events like weather, flooding, or construction work. Today's lack of cameras and vehicular tracking technology and management can make it difficult to identify crashes quickly and formulate a tactical response. Crashes and other roadway incidents can take several minutes to identify, which impacts survivability of those involved. On average, it takes 10 to 20 minutes to get emergency responders on site. Critical crash events can take several hours to clear. According to the Federal Highway Administration, every minute it takes to clear a crash increases the chance of a secondary crash by 2.8%. On average, segments of I-29 are closed around 13 times each year due to extreme weather, flooding, or traffic incidents. These closures total several hundreds of hours of cumulative delays for the supply chain and local commuters. So, what is the Smart 29 project and how can it help? SMART stands for Safety, Mobility, Automated Real-Time Traffic Management. Let's break down each component. A key feature of the Smart 29 project will be variable speed limits from the Fargo area through the Grand Forks area. Variable speed limits factor in real-time travel speeds, weather, traffic incidents, special events, and work zone information to incrementally reduce traffic speeds ahead of a congested or unsafe area. According to the Federal Highway Administration, this approach to traffic management has been proven to reduce total crashes by 34%, fatal and serious crashes by 51%, and yield a benefit-cost ratio of as high as 40-1. On I-29, where the vast majority of crashes are caused by events such as weather, earlier incidents, or work zones, the benefits are expected to be even greater. As many as 76% of crashes between 2019 and 2021 could have been positively influenced by variable speed limits along I-29. Reducing these crashes and associated delays would yield an annual benefit of $112 million from this project alone. Through Fargo, ramp metering will be deployed along I-29 and I-94. The I-29 and I-94 interchange is the most significant crash and congestion node in the entire state. Bottlenecks at and around this critical interchange create over 65,000 hours of delay annually. Growth through the Fargo metro area is expected to double traffic demand on I-29 by 2050, which will exponentially impact travel times and freight reliability through the area. Preliminary analysis indicates that ramp metering has the potential to reduce 75% of peak hour delays and reduce critical travel times by 50%. This is consistent with applications in the Minneapolis-St. Paul metro area and more than a dozen other tested applications across the country. Ramp metering is also expected to reduce crashes in the area by as much as 50%. Ramp meters are traffic signals installed at freeway on-ramps to control the frequency at which vehicles enter the flow of traffic. Ramp metering would only operate when mainline traffic congestion approaches unacceptable levels, meaning it's estimated that the system would only operate for a few hours a day. During those times, it may be best for local drivers to utilize local routes to facilitate improved operations for regional freight and commuter trips. Various automated spot improvements will be deployed along the corridor. The following locations were identified through a detailed analysis of crash history and stakeholder interviews: This list includes curve warning systems at targeted high crash locations to reduce run-off-the-road crashes. Curve warning systems only flash when drivers are moving at a speed above safe operating conditions, which are adjusted based on current roadway conditions, like rain or snow. Alternative routing systems at locations prone to flood and temporary closures. This concept combines multiple intelligent transportation devices into one system, including high water warning systems, dynamic message signs, and automatic gate systems. Wrong-way running prevention systems at targeted wrong-way running crash locations. Wrong-way running prevention systems use video detection and active warning signs to try to prevent wrong-way running, along with mainline dynamic message signs and alerts to notify mainline drivers. Bridge de-icing systems use sensors to identify conditions conducive to bridge ice. Using nozzles embedded in the bridge, de-icing substances are sprayed on the road to improve friction and reduce crashes. Electronic road closure gates allow field staff to remotely close gates at safe locations. When gates need to be closed, roads are typically at their most treacherous. Remote operations will keep field staff out of harm's way. Truck parking information management systems provide real-time parking availability information to drivers. Vehicle detection at rest areas and/or truck stops can be relayed through dynamic message signs. The North Dakota Roads Map and navigation systems to long-haul drivers. Smart I-29 will use crowdsource and connected vehicle data to identify and anticipate events along the corridor. This data tracks field sensors, Bluetooth devices, and connected vehicle harsh braking data to identify incidents. 10 other states and many other major metropolitan areas are actively using crowdsourced data to help identify incidents. Studies have found that the use of crowdsourced data can reduce the time it takes to identify an incident by 35 to 50% compared to manual surveillance or waiting for public calls. This has a direct impact on survivability at crash sites where every second counts. Through the Smart 29 project, the North Dakota Department of Transportation will update their ND Roads smartphone application to allow for some critical features. This will include the option to push alerts, either via notification or voice, of upcoming incidents based on your location. This will allow drivers to dynamically adjust speeds to reduce crash potential, or adjust their routes entirely to reduce delays. The ND Roads application will also provide alerts to an increasing population of connected vehicles along the corridor, such as maintenance vehicles, snowplows, and emergency vehicles. Nearly the entire corridor will be visible via video monitoring, which can be accessed from the Transportation Management Center that will be staffed on a 24/7, 365 basis. This level of video coverage and management has been found to reduce crash clearance times by as much as 50% in states like Wyoming and others across the country. A 50% reduction in crash clearance times will help prevent secondary crashes and reduce delays along the corridor. When driver and freight benefits are quantified, the benefits are expected to equate to $13.5 million annually. In total, the Smart 29 corridor has the potential to positively impact hundreds of crashes per year, save millions of dollars of delay, reduce response and clearance times, and provide better information faster to the driving public. Best of all, the cost of this technology is a fraction of the cost of traditional roadway reconstruction or widening projects. Nationwide, the benefit-cost ratio on intelligent transportation projects is more than double that of traditional improvements, meaning Smart 29 is not only a smart corridor, it's also a smart investment.